Hi and welcome. Behind me I have Learn from Water, a piece of art created by Hon Ma Jun in 2015. The irregular shapes, they represent water droplets being blown by the breeze, and from below we can see the reflection of the greenery in them, and from the building behind it, from the classrooms, you can see the reflection of the sky from above. Now, my name is Torbjörn Nordling, and I'm an assistant professor in automatic control at the Department of Mechanical Engineering at the National Shenggong University in Tainan, Taiwan. I'm also the general chair and organizer of this workshop. Now it's my great honor to introduce our honorary chair, Chair Professor Wu, who will welcome us all.
It is a pleasure to welcome all of you on behalf of the National Shenggong University in Taiwan. I'm proud that our team, the NCKU Parkinson's Disease Quantifiers, are one of the finalists in the OpenCV AI competition. They are also arranging this workshop. Now let us all learn computer vision and AI using the OAK-D camera together.
Hello and welcome. I am Akram Ashani, postdoc researcher at the Department of Mechanical Engineering of National Shenggong University in Taiwan and assisting chair of this workshop. It is my honor to introduce Mr. Sachin Sharma, who is a founder at Funoppia. He is an experienced data scientist and has been working in the field of artificial intelligence and machine learning for the past 2 years. He loves to teach and empower students. He co-founded Funoppia, that is an Asia's first visual AI platform. He will present AI and machine learning for young minds using Funoppia's FunAI IDE. Please enjoy it.
Hello, Mr. Sharma. Hello, Mr. Gupta. We are online now. Thank you very much for joining us. I'm the host of today's workshop and the Q&A session. Today, Mr. Sharma will present AI and machine learning for young minds using Funoppia's FunAI IDE. Now, let us enjoy Mr. Sharma's presentation together.
Yeah, thank you so much. So, hello and namaste, everyone. First of all, I would like to thank Nordling Labs for giving me this opportunity to share some knowledge with all of you. So, I am Sachin Sharma, and today I will be showing you how AI and machine learning can be simplified. And we will be learning about computer vision, CNN, and we also will be creating a project at the end. So, let's start with the session. So as you can see the agenda over here, as I already told you that we will be learning about computer visions and we will also be creating our own network architecture, and that too using both blocks and code. And at the end, we have a project waiting for us. So let's start with the session. So before we actually begin with the computer vision and all, let me first brief you about Funoppia. So Funoppia is basically the Asia's first visual AI platform for learning AI, machine learning, and Python, and that too intuitively using both visual and code mode. So the next question is why we founded Funoppia. So after talking with a lot of students and teachers, we realized that many students or professionals drop out from AI and they don't want to take up the field just because they believe that it is hard. And we just wanted to break this myth. So that's why we created Funoppia and we created an ID for it. So with the mission that no learner is left behind, Funopia empowers students and teachers to learn AI intuitively and visually. So that's about Funopia, and also the platform is totally free to use. Anyone who wants to build projects and all can go ahead and start making it and start sharing with their friends or colleagues. And the platform is designed basically to accommodate learning for both school students as well as for the engineers. Now, I'm glad to share that this information that students with grade as low as seventh and eighth have created projects on our platform. So now, what we have to offer on Funopia? So at Funopia's ID, student can or they can do Python programming whole in the browser. They don't need to set any environment over here, and they can also do machine learning and all. Now, let me show you a little magic of linear regression, how we can do it on the platform before we actually jump in to learn the computer vision. So let me open up the platform. So this is the platform I was talking about. Now over here, I'm just quickly going to load up a notebook, basically a workbook of linear regression. The linear regression you might be knowing as it is an algorithm to basically predict or forecast on some data set. Now over here we have a data set which is called Old Faithful. Now before explaining this, let me quickly run this. And as you can see, as any project a pipeline, any project follows, which is basically loading some libraries. You can see matplotlib, numpy and pandas, then loading the data set, then doing some pre-processing over it, and at last putting the algorithm over it, and then taking out some predictions and measuring the accuracy. So you can see on the right side, this particular data set we have is of basically cone geysers. Like it basically predict how much is the waiting time before next eruption of a geyser. So this is the data. This is how data set looks like, and it is a description of the data set, and you can see the accuracy as well. Now we can tune in the accuracy by changing some hyperparameters over here, but the key thing is these graphs. As you can see over here, we have an input feature and we have an output feature, and you can see how well the line has fitted to our data set. And you can see that we have to predict over here the waiting time for the next eruption, which is our basically independent variable. That is what we are predicting here, and that's what is happening here. And also this is our error graph, how our error is decreasing as the iteration or epochs are progressing. So now you can relate that what I meant by when I said that it is very easy, like joining the puzzles to learn any algorithm, any machine learning algorithm you can find over in the toolbox here. So now let's get back to the presentation. This was about the little bit about linear regression, and now let's go ahead and learn about computer vision. So computer vision is basically a subfield in artificial intelligence, and this particular field basically deals with the digital images, videos, and any visual inputs basically. And also there are excellent libraries like OpenCV out there where we can perform the computer vision, and we basically use computer vision to do tasks like semantic segmentation, classification, object detection, and instance segmentation. So, and apart from these, I would say from facial recognition, self-driving cars, augmented reality to we can say that in all these, computer vision plays a vital role. And apart from these applications, let me tell you, computer vision has enormous application. We have optical character recognition, which is basically taking out some text out of an image. And we have 3D reconstruction, games, surveillance, HCI, automation. You get the point that how computer vision is how computer vision plays a vital role. And to do some computer vision tasks, the thing we use is basically deep learning. So deep learning uh, is very effective algorithms we have for basically do the computer vision task. For example, in specifically convolution neural networks. Now, convolution neural networks is the fundamental architecture for performing computer vision tasks. Now, we will be talking about this in detail, like what is a convolution and what are convolution neural networks. So, this is like a gist of convolution networks. So, we have an image at the left side, you can see, and we have a network in the middle, and at the right side, we are getting some predictions. So, we basically feeding the in feeding the image in the network, and the network in return giving us the output that what image is of. For example, this particular example, we are classifying between dog, bird, and cat, and this is a image of a bird. That's why our model is saying that yeah, this is an image of a bird. But the question is how our model or how our architecture is predicting all these. How is training going on, and how we are feeding in the image. So for that, we first have to talk about images. Now, some of you might be familiar with this that images are made up of pixels. Now, what is a pixel? Pixel is nothing but the smallest unit in the image, and it contains a number value, which basically will decide the actual color of that particular pixel. Now we have different channels as well in the image. For example, if you have a grayscale image, then you will have only one channel. And if you have a colorful image, then you will have three channels: RGB, red, green, blue. And a combination of these numbers will decide the color of that pixel. You can see on the slide. So we have an image at the left side, and on zooming it at some particular area, we can see the actual values of the pixels. And on the right side, you can see we only have as a majorly we have RGB, and with the combination of all these, we make different colors. For example, red and blue makes up magenta, red and green makes up yellow, and all these combined make a white color. So you can see we can mix them in some proportion, or in specific values we can make a color. And now let me show you one beautiful website I came across, this one, to demonstrate the pixels. So you can see I have an image over here, and if I try to zoom in, so what happens is, as you can see, as I zoom in very furtherly, like I get the actual value of the pixel. For example, this particular pixel has a value 164 as of red. Then for green it has 171, and for the blue it has 178. And you get the gist that what is happening here. Every pixel has different value, and these values are basically determining the actual color of that pixel. And when we combine all these pixels together, we get a image. Okay, so this is how an image is formed of. Now you can think of like instead of image, consider it as a matrix with some values. And let me tell you, these values varies from 0 to 255. Okay, now you know about images, like which we were feeding in the network. Now let me show you this convolution. So I have been using this term so many times: convolution neural network, convolution neural network. But what is a convolution? So if I have to talk in terms of like some mathematical function, two functions combined together gives a third function. This is what convolution is in terms of mathematics. But what is it in terms of convolution neural network? So consider that we have an image, and we are applying a filter over it. Now, what's a filter? filter is nothing but you might be using it on social platforms as well, like which is basically getting out the boundaries of your face or body, and that is a filter. And filter actually contains some numeric values, and we apply this filter on our image. And you can see in the right side this filter of size 3 cross 3. This is also known as kernel as well, if you have heard about it. So, and at the right side I am getting a some value. We are basically multiplying these values and adding them up, and which is in return giving us a feature map. Okay, so we are putting some filter on an image and we are getting a feature map as output. You can also see like if it how well basically a filter can determine the boundaries. So if the color is very much distinguishable, we can say that we will get a edge point, exactly edge point. And if you can see it, if it is a little bit blurry and all, then we will get edge like this on the right side of the bottom. Now let me also show you different kind of filters. For example, consider this filter. We have a matrix down below which contains some numeric values, and if we apply that matrix on the image, we are getting outlines of the image, you can see. And similarly we have different type of filters. Let me show you that also. Yes, so you can see this particular matrix will determine the outline of an image. You have the demonstration down below. And if I change the type of filter, let's suppose sharpen. So sharpen is basically sharpen edge, as the name suggests. Similarly, I have different type of filters, and you can see each time I'm changing a filter, I'm getting different values in my matrix. And let me tell you that people used to find these values using hit and try methods, which is a lot of hard work, I would say, because they used to change the values of each and every position, then see if it is giving us a desired output or not. And at last, they finally got these metrics. But thankfully, in deep nets, in any deep neural nets, they are based on universal approximation theorem, which basically is what it is. So basically, it can predict values and between any specific range. It can predict any continuous function. This is the beauty of universal approximation theorem. And CNN or any deep nets get these matrix value of these filters by its own. It basically first randomly assigns some value to the matrix. Then during the training, it will keep on updating those values. And after the training, we will get our final kernels, filters, and all these. Okay, so now you have an idea of what is a convolution, what is an image, and how we performed it. Let's look at back with the example we had, that now we have a network, we have an image, and now you see what is happening in the network. We are basically, if it is a convolution layer, we are performing some convolution over it. Okay, so next thing is creating CNN network. Okay, so we have talked about there's a layer, something called convolution layer, which will basically perform convolution on an image. And similarly, we have different type of layers like pooling, fully connected, you can see dense layers, and we have output layer and all this. So we will be building this network by our own. But first, let's also talk about what is a pooling layer, so that when we are building it, you guys will have an idea that what we are doing. So pooling is basically used to drastically decrease the size of our input. Okay, but keeping the most important information out of it. Now you can see I have a box which has value 12, 28, and 12 again. Okay, then if it is a max pooling, then I will take out the maximum value out of this. So which is 20. So I will put 20 over here. And in the next matrix, you can see the maximum value is 30. In this one, we have 112. And in this one, we have it as 37. So this is max pooling. So earlier we had an input of size 4 cross 4, which is total 16 values. And in the output, after just performing a max pooling of 2 cross 2 matrix, we got an output as 2 cross 2, which is total 4 value. You can see how drastically the size has reduced from 16 to 4. So this is what pooling is used for, to by keeping the useful information out of the pixel and by its neighboring pixel basically. And this is how we perform max pooling. We also have a concept of average pooling, where we will, instead of taking the greatest value, we will be averaging all 4 values, and that value will be putting in the output. So this is what pooling is. And we now know convolution, pooling. Fully connected is just a normal artificial neural network, which is it is basically a classifier. And now the next thing we should know is how it is updating the values, what is happening inside the network. So you can see, first we initialize weights and biases randomly. Okay, then in the network, we provide some input and it will go through the network. And you can see at the last I have a sigmoid activation function. So activation function are basically used to introduce some non-linearity inside our network, make it more a little bit complex. So now let's suppose whatever input I provided, I got I got a value as loss. Okay, then what I will do, I will just put it back to the network again. That it is your problem, you have to solve it. So I will just put the loss back to the network, and the network will learn from its mistake and will update its parameters, basically the weights and the biases. And it now, in the next iteration, the forward path will be taken with the updated parameters. So it is like this, forward, backward until it learns completely. So this is how basically training goes inside the network, and this is how it updates its values. So you can see we have different type of networks. Like I just showed you one. We also have different varieties of network. You can see on the screen we have Markov chains, we have recurrent neural network, LSTMs, a simple perceptron feed forward, and you get the idea. Like it's not any hard and fast rule that you have to design this particular network only. It depends basically on the use case. Now moving on, let me yeah. Now let's see this network in action. We will be creating our own architecture, and we will be printing the summary of it. Basically we'll be visualizing what our network looks like. So let me go to the platform. Yeah, let me delete all this. Now in our network we had two convolution layer, two pooling layers, then two dense layers, and one output layer. So that network I'm going to build here. And it's not like that you have to build this only. You can build any architecture basically you like. So first, let me also show you the code. So as soon as I drag a block, automatically that code appears on its own. So first I am initializing that what will be my model type. So we basically have two types of models, sequential and functional model. So we are building a sequential model, that's why I'm keeping it this only. Now I have to store my model somewhere, but I created a variable and I'm going to store my model inside the variable name as model only. Okay. Now the next thing is I have to create the architecture. The very first layer was of convolution layer. So this is a convolution layer in the CNN. I'm taking it out. And all I need to do is I have to provide the model name, so which is model only. So I will taking it from the variables. Next, I have to provide the number of kernels I want in my first layer. So I will be explaining you this kernel concept more in the when I will visualize. I will be showing it you visually. So next is, let's suppose I want 128 kernels. Okay, and next I can also specify what size of image my model should expect. So it is now 120, 120, 3. I can change it to 224, 224, and 3. Okay, just like this. So this is my first layer ready. You can see the code as well. Now let me just put this as inline. Yeah. So next layer was of pooling layer. So I have an pooling layer here. All I need to do is drag the block, and I need to provide the name of the model, just like this. So you can see the code max pooling, and also I can provide the pooling size over here, but I don't need, so I'm just gonna keep it as 2,2. Next thing was we had one more convolution layer. Now what I'm going to do, I'm just gonna copy paste it. This is my convolution layer, and in this layer I'm not expecting any input shape. Basically it is coming from the previous layer only. Previous layer output becomes the next layer input. Next thing I have to do is max pooling one more, and I'm going to apply uh, global average pooling. So yes, all I need to do is just provide the model name for which I am going to use this. Now this was my convolution network. Now I have to put a classifier on top of it. So for classifier, okay, expand inline. Yeah, for classifier, I am going to take out some dense layer, basically the fully connected layer. So I have a dense layer in my neural network. I'm going to take it out. All I need to do again is provide the model name and how many neurons I want in this my fully connected layer. So let's suppose we had 128 in the very first layer. Let's change it to 256. I'm putting these as random numbers just to show you. Let's again have 128. Then after a dense layer, I want to add some non-linearity in my network. So I'm going to put some activation layer out after this. So all I need to do again is provide the name of the model. Now I can select my activation, Raylo, Sigmoid, Softmax, 10H, anything I like. So this is my basically activation layer. Now next is I want to add one more dense layer. So here, let me change it to, let's say, 64, and one more activation layer. Now let's consider this as our okay, let's add one more layer only. Then that will be our last layer, which is basically the output layer. So at output, let's suppose my architecture is going to predict between three categories. Okay, so at the last layer, I have to write the number of neurons as same as the number of my categories, which is 3. So in this case, I have to write 3. And the activation at the last layer should be softmax. If it is a binary, then you can go ahead and use sigmoid as well. But yeah, so this is my architecture, and you can see the code as well. Okay, next thing I want is I want to basically print the summary of my model just to show you it visually. So I'm going to do this, and all I need to do again is provide the model name. Now at last, one more thing I want to plot is we have different type of blocks. So one block is of plot your model, which is basically convert our model into a image. So in that way, it is more intuitive. So I'll just go ahead and put this. Now my model architecture is ready. So you can see the code, and let me also quickly load Akira's library. Now I'm going to do this on Google Colab. So we have a button over here, Google Colab. So all you need to do is click on that button. Automatically the whole code will be copied to your clipboard. And as soon as your notebook is ready, so I'm going to paste the code, and let me just connect my notebook. You can see all the code we basically made on the platform is here. Now let's wait for it to connect, and then I'm going to run it. Yeah, so basically it is initializing and connected. Yes, so you can see this is the summary of architecture. So also, if you don't want to read it like this, you have an image that this is my first layer, then this is my max pooling second layer, then again a convolution layer. Okay, let me also explain you some of this. So at the first layer, I provided the input as 224, 3, and I did a convolution on it with a kernel size of 3 cross 3. So that's why my, let me change the size. Yeah. So you can see at output, I have got the size as 222, 222, comma 128. So 128 is the number of kernels I provided in the very first layer. And how it is changing the shape? So basically we have a formula which is n minus f plus 1. So I can n minus f plus 1, which is n is basically the input shape, which is 224. Then we have f is the basically filter size, which is 3 cross 3. So I'm going to just put 3 over here, and plus 1, which comes out to be 222. This is how we got a shape of 222 cross 222 cross 128 at our first layer. So 128, again I am saying 128 is the number of kernels at the first layer. Okay, and in the next layer we have a max pooling. So max pooling, as I told you, that it will basically reduce the size from 16 to 4. Remember, and over here we had the size, as I already said, that input output of previous layer becomes the input of the next layer. So now I have 222, 222, and 128 as an input, and I am applying a max pooling. The max pooling will, if it is a size of 2 cross 2, then it will just make it half, like as you can see on over here as well. So it's now 111, 111, and 128. 128 is the number of kernels again, because max pooling basically will not change the number of kernels. And you can now you can say that at the second layer I have this size with 128 feature maps. Okay, now you can follow that what is happening in the network afterwards. So this is all you have to do is apply the formula, and you will these numbers will match with your calculation. So this is a visual representation of architecture we just made. Now this was about the architecture, creating the architecture. We saw it in the action. Now next thing is, one question I came across a lot of times is, what if I have a small data set? So because I would say that deep learning algorithms or their architectures are data hungry. So they need a lot of data to basically give us a better result. Okay. So what I would recommend is, if you have a very small data set, then try some other algo. There are a lot of algorithms. But if it is of decent size, then we can try a few things. For example, over here, we can try augmentation, which is basically changing the. You can see we are here mirroring image of a cat, and we can just slightly crop it. We can rotate it, and all these things we can do with our data set to increase the number of images in our training data. And the next thing we can do is transfer learning. Now, why I am bringing that concept of transfer learning is because when we'll be making the project, so we will be using the transfer learning. Okay, so what is transfer learning? So transfer learning is basically, I would say, use the use someone else's trained network over your data set. So there is a competition which is known as ImageNet competition, which held from 2012 to, I don't know, from for 15, 16, 2015 and 16. But in that we came across several different networks. So the first one was LXNet, then we had ResNet, MobileNet, we have VGG, VGG16, VGG19, all these networks. So basically they all are trained on ImageNet data. Now we can use that learning in our project. So all we can do is take out the network and put a classifier on it for our own data set, and we are good to go. And how we can do it? So why we do it? So usually in every project or any classifier, usually the first initial layers determine the outlines and all, basically. So that's why we can use transfer learning. And in this case, your data set must be a little bit similar to the data set on which ImageNet has trained. So this is the thing you should keep in mind before using transfer learning. And this is transfer learning. And you can see one of the network, this is a VGG architecture. You can see it is nothing but a simple network architecture, but the number of layers and the number of uh, kernels in each layer has been determined by them during like repetitive iteration, like which suits best for them. Now let's now build the project. So let me first show you the project. So this is a Masketon project, which is a basically mask detector. So it is right now loading a model. Yeah, you can see the model is loaded now. It is saying I'm not wearing any mask. So let me wear a mask. As you can see, as soon as I wear a mask, it is showing it in the green color with some accuracy. I am wearing a mask now. Now let me remove it, and yeah. So we basically have trained a network on this data set, which is basically of uh, persons with mask and persons without mask, and that's how we got it. So we will be building this particular project here. So now we have seen all the prerequisite, I would say, to basically get an idea of how we work in deep learning. So, but let me tell you, creating the AI project is just like baking a cake. Now, how do we bake a cake? So we basically we have several steps, I would say, in a process of baking the cake. For example, like the very first step is collecting all the ingredients, and then we have a step that which is basically mixing the ingredients in the right proportion. Next step is pouring the batter into the mold, which basically, carefully see that, determine the layers of our cake, how many layers of cake we want. And next step is actually baking the cake. And next step is inspecting whether it is properly made or not, and at last putting some decoration over it. And the very most important step comes at the last, which is tasting the cake, which if it is tasting good or not. Yeah. So these are the steps of baking a cake. Now let me show you the steps of creating an AI project. You can compare them sideways. The very first step is loading the libraries, then collecting the data set and doing some pre-processing over it, then creating the architecture, which basically will determine how many layers of network we want. And next is training the model, then visualize the training, basically how our training went, and then by testing the model. Okay, so now I'll be showing you these steps. So this is here we were. I'm going to go to the project playground, and I'm just going to click on the code button for the Masketon project. So I have now the the fully block for the project. So let me take it to the full. You can see the code as well. So I'm going to take this in the full screen. Yeah. Now let me divide this for you guys. So so that it will be easy to compare it with the step I just told you. So this is the architecture and this is the training, and let me just zoom it out. Yeah, and at last visualizing it. You can see I have divided my all blocks into 4 steps, 5 steps. The very first is collecting the libraries like matplotlib, numpy, pandas, keras. These libraries have different purpose, and then we are loading the data set. The data set is called Masketon image data set, and the image size we want is 224, 224, 3. And this size must match with the input size we have to provide in the very first layer. Now here we are doing some pre-processing like shuffling the data set little bit, and then we are now using transfer learning. So transfer learning, in specifically transfer learning, I'm using the architecture of mobile net. Okay, and I top false means that I'm not including the top part of the mobile net because I'm gonna build my own architecture, my own classifier basically. So that's what I'm doing. This is my the basic base layer of my network, and now I am building architecture like basically a classifier. I have a global average pooling layer, then I have dense layers where I'm describing the activation function or number of neurons in my network. This is basically a functional model. Earlier we saw the sequential model. This is a functional model where we are connecting two different models and we are getting the third model, final model basically. So this is how a functional model looks like. And now we are making some layers non-trainable so that we don't have to train it. We are going to use the weights from ImageNet dataset only. Then we are compiling the model where we are defining which type of loss I want to basically uh, sidewise calculate, like I can see how my training is going on. And I'm choosing an optimizer is basically responsible in updating the parameters I told you earlier, and I'm describing the metrics as accuracy that I want to judge it with the accuracy, how much accuracy I'm getting at each layer. And now I am fitting the model. So model fitting is how many epochs I want to train it on. Let's say it is 15. How much batch size I want to have for my training, that how much images I want at one time, and then how much I want to split for the validation. Then this is just a shuffle. And after the training, what I'm doing is this, plotting some graphs to see it visually how my training went. And then I'm doing some predictions. Then I'm plotting a confusion matrix to basically see how well my model has performed on test dataset. And at last, I'm also downloading my model, save and download model. You can see it so that I will show you why we are doing this. And we are also plotting the image of the model. Okay, so let me now take it out from the full screen. And as I showed you earlier, all we need to do is click on the collab button and it will automatically take our dataset there. So let me just attach these. This is my whole project. So I'm going to click on collab now, or I have this notebook as well, so I can copy here as well. So just copy, and I have to paste it automatically copied on my clipboard. So this will take a while to train. You can just go ahead and run it. So luckily I have already made a notebook for this. So just to show you guys like visually. So as you can see, the very first step was collecting the images and loading the libraries. You can see libraries loaded, now loading the data set. And in that data set, I have this mapping, which is basically my images without mask is labeled as 0 and with mask is labeled as 1. And these are the sample images from the data set I have. Is like these are from without mask. I have these much images in my each category, and you can see these are samples from the data set of with mask. And now this was the first step. Next, we are building the architecture. Since we are using the mobile net architecture, you can see that's why our architecture is so big. And also I have plotted the image for it like down below. And now comes the training part. So you can see the compile and fit I showed you on the platform, and we are plotting some graphs for it. So I have trained it for 15 epochs, and just in a hurry, little I will in a little bit hurry. So you can see I'm getting 100 so much time. So that means I need to tune in few parameters. Maybe it is overfitting and all. It is a training accuracy, but in validation accuracy, I'm getting a good result. So you can visualize it using the graphs as well, how the loss was going on and how the accuracy was going on. So this is the graph. And now the confusion matrix. You can see how confusion matrix performed, how well confusion matrix has performed. So over here, I can say like 40, 45, it's 90 or 91 accuracy. I will say that my model has got in that on the test data set. This is for the test data set. Next thing is the image of the model. You can see, you can read it if you want. And now I'm taking out some predictions. You can see this particular image, it is classifying it as without mask. Now let me go ahead and change it to some different image if I can. Okay, actually the collab notebook got disconnected, and that's why I have to run it all over again. So this is why it is not showing it. But anyways, let's proceed further. And you can see at last I am downloading a model. Now why I am downloading the model? Because we have provided a feature on this basically project that anyone can train their own model and can upload it. So I already have a downloaded version of my model. So I'm going to just upload it. You can see I'm just giving my name and I have to choose a file. So yeah, this one. I just trained it. You can see the time. Uh, and I'm going to upload it. You can see the background color change. That means the model has successfully uploaded. And now I'm going to start it. So it is setting up environment for my model, and now it is working. So where's my mask? Yeah, here it is. So it is now showing that I'm not wearing any mask. And let's see. Yeah, you can see a little bit. It needs a little more training, but you get the point that how you can test your model on camera as well. So this is how you create a full-fledged project with all the basic steps I have shown you. And not only this, we can also build projects like let me go to the like we can also build projects of NLP. If you have heard about it, it's natural language processing. So I have this project with me, which is basically NLP project. Here I'm instead of convolution, I have layers of RNN or LSTMs. I showed you in the old type of networks when I showed you that image. You can see the layers. So this is how you can how easily you can build your architectures and you can train your data set on it. So this is it from my presentation. I showed you the NLP as well, and this is it for today's session. I hope you all liked it. Now, if what's the next step? Do we have some questions? Like, If I have some anyone has asked some question, they can go ahead. I guess this is streaming live on YouTube.
Yes. Thank you very much for the great talk.
Yeah.
So we will put the link of our Google Meet in the chat later. So if any
Okay.
audience want to join us, please feel free to click it. At the same time, let me read out the question in the chat for you.
Okay.
So the first question is, thank you very much for the interesting presentation. The Funoppia looks very cool. Does it have any limitation? What kind of new feature you would like Funoppia to have?
Okay. So Funoppia, we have created this platform now. We are continuously adding more and more features on it, and you can see like I've showed you the models. Now we are planning to add some pre-trained models as well, and that's how that's a different thing we have in the roadmap. So we'll be adding more and more features in future.
Thank you very much. The next question is, that's very interesting. What is your favorite part of Funoppia?
My favorite part of Funoppia. So it is that this particular platform we have built is bridging the gap between what students think and what they can do. So this is my favorite part, that we have got this opportunity to make such a platform where anyone can learn AI or machine learning, and that too intuitively, and yeah, and not only like blocks, they can also write their own code in the editor. So this is the best part, that they can switch anytime they want from block to code.
Thank you very much. That's very good vision. The second one, the third one is, can Funoppia
Hmm.
do something opposite? Can you copy paste the code and export the beautiful Lego plot?
Okay, so you can is the question is like putting some else's code on the editor and running it, if I am getting it correctly. Then yes, you can go ahead and type your own Python code from some other sources, and you can go ahead and run it here. You are free to use this.
I think the question from that is like, you have the left side is your plot, like Lego, you can move block by block, and right
Yes,
side
yes,
is the code. Can you do
yes.
opposite, like copy paste the code in the right side, then go to the left side?
Okay, okay. You are asking that if I write some code, then automatically block will appear. No, we don't have this feature right now. Like you can't do this by writing your own code and getting the blocks. Unfortunately, you can't right now.
Okay, thank you very much. The next question in YouTube chat is, how many layers we should have in our network?
Okay, so this is an interesting question, and a lot of students get caught in this question. Basically, I would say that it depends on your data set. If you have a data set which is linearly separable, then you don't need any hidden layers. Okay, and if you have a little bit more complex data set, then you can there's a method which most of us use, which is basically creating different architectures, and then seeing which one is performing best on the data set, and basically according to the use case, and that's how you can decide the number of layers you want in the architecture.
Thank you very much. The next question is so far the last one. If any audience want to give more question, please feel free to put in the chat. So question is, thank you for the great demonstration talk. The Funoppia looks really cool and attractive. Are there any requirements or limitation on users' computer equipment?
Okay, you just need to have a decent laptop, I would say. You not with very high computation, because all these thing is like in browser. It is all client side. So it's up to your laptop. Like if it has a basic configuration like 234 GB RAMs, and you have a browser, then you are good to go. You don't need any other requirements.
Thank you very much. So now I see there's no question pop out. So I think this is today's the end of today's workshop. Thank you
Okay.
so much for the answer.
Thank
For
you so
more
much for
information,
having us.
sorry for interrupting. So, for more information, we'll have our network event at tomorrow 2 p.m. And please check our website. We'll put the link in the chat. Look forward to seeing all of you. Thank you, everyone. Thank you, Mr. Sharma.
Thank you so much.
Thank you. See you. Take care.
See you. Bye bye.